Okay, for number 3 it says a 20 centimeter diameter 2 kilogram hover puck is sitting motionless on a frictionless floor. It shows us this hover puck from kind of a top view, and we're looking at this foot that's kicking it, and it can kick along these dotted lines, either A, B, or C. It says at first a 5 Newton kick is applied to the hover puck. Determine the net force and the net torque on the hover puck when the kick is applied at each position. And at A, at B, and at C. Okay, well, first of all, let's consider the hover puck from a side view. So this, again, is the top view. This is top view. Or bottom view, whatever. And let's look at a side view now. Side view. Okay, so here's the hover puck. There would be a support force on it from the floor, straight up. There would also be a weight force acting right at the middle, straight down. And there's going to be this applied kick that's kind of like this, I guess. This is going to help us figure out the net force, this free body. So again, this is the weight on hover puck from Earth. This is the support force on the hover puck from the floor. And this is the force on the hover puck from the kick. Oh, I think it's pretty obvious that the net force for every one of these, A, B, and C, must be the same. These two forces here cancel out, the support force and the weight, so therefore the net force for all of them, I don't want to write it multiple times, but the net force for every one of them, F net, is going to be equal to the force on the puck from the kick, which is always 5 newtons. Always. Okay, now the torque, in order to figure that out, we have to look at this top view. And for A, we've got a situation like this where it's applied right along kind of this direction here. So that's where the force is being applied for the kick. So again, this is going to be the force on the puck from the kick. There aren't any other forces here as far as causing rotation. So that means that the net force for A or the net torque, I should say, T net, is going to be equal to the torque from the kick, which that's going to be equal to the 5 newtons times the distance away, which is 0.05 meters. And that's going to be equal to 0.25 newton meters. Okay, so then at B it's going to go right through the center. So this is what it would look like for B. We have again the hover puck, and we have that same force, but it's applied right through the center. Okay. Force on the puck from the kick. The lever arm for that is going to be 0, and so the torque for this one, the net torque, is 0. T net equals 0, and that's because you still have the 5 Newton kick, but it's going to be multiplied by 0, the lever arm. Okay, then finally at C, again we have the hover puck, and now that force is being applied tangentially right at the very edge here. So here's the force on the puck from the kick. So the net torque in this case, T net, is going to be equal to that 5 newtons times the distance, and that's going to be the radius, which is 0.1 meters. And that is equal to 0.5 newton meters.